Hi, we've already seen how to initialize a variable in Python, how to do basic operations, and how to ask the user to input a certain value and then output it in the terminal. Did you ask yourself, how can we store data in Python? Today we'll be solving this issue by talking about the lists, the tuples, and the strings. We'll be starting the session by giving the solution to last time's exercises, and then we'll tackle the theoretical and the practical aspect of these data storing structures. Let's get started. First exercise we talked about was to create a Python program that asks the user to enter their birth date and outputs the age of the user. For example, if the birth date is 2000, we want to output you are 23 years old. Let's go. We will start by asking the user to give us their birth date. So we'll create a variable called birth date and say it's equal to the integer, because it's a number, so we want it to be an integer, of input function saying please enter your birth date. We now have the variable birth date that normally contains, in this example, the number 2000. So what we're going to do is print using formats, you are braces years old. And in the braces, we'll do the subtraction between the current year, 2023, and the birth date. And hit run. Here we can say 2000, and it will give us the desired output. Let's now tackle exercise 2. In order to create this rectangle using the hashtag symbol, we will proceed line by line. First of all, we'll start by printing the first line, this one. And let's say we want 10 hashtags. We don't need to get the same number as in here. So we can print hashtag times 10. If we run this line, we'll see the first line of the rectangle being printed. What about the next line? So the next line, I'm going to call this one line 2, is made by printing one hashtag, not going back to the line, so using and equals quotation marks. Then we want to print the space between the two hashtags. That normally contains 8 spaces. So at the line, we're going to print the space times 8, and we're going to end this by saying and equals quotation marks for us not to do a line break, because we still want to print this hashtag on the same line. And then we'll print the last hashtag saying print hashtag. And in this case, we don't add the and equals quotation marks. We want to go back to the line. If we run the code, we'll see the rectangle being created. What we can do is copy and paste line 2 several times. So let's say we're going to do this twice, and then end by printing this last line, which is exactly the same as the first one, but we're going to call it line 5. And here we can hit run and see the square or rectangle. Our first topic for today are the lists. What are the lists? You can think of a list in Python as a box where you can put many variables, many numbers, many objects of any types. The way we initialize a list in Python is by saying L equals brackets 1, 5, 3, 20, and close the brackets. So this is a list that contains 4 numbers which are separated by commas. There are 2 major things you need to know about these boxes that we call lists. The first one is that a list is ordered. Why ordered? It's ordered because the order and the succession of numbers in this list matters. If you switch the numbers, you will have a different list. So even if 2 lists contain the same numbers with different orders, we can consider that these 2 lists are different. How do we represent this order in the list? We can represent this order by using the index, which goes from 0 till the length of the list minus 1. In this case, the length of the list is equal to 4. Len of L equals 4. Last time we saw the function len that is used to measure the length of a string. Len is also used for lists to measure their length. The index here goes from 0 till length of list minus 1. Its second main characteristic of this list is that it is mutable, which means that even after creating it, you can still modify it and change some of its elements or even all of them. What we'll do now is create a new file called course3.py and start playing with this new list. To initialize a list, we can call it L for list equals open brackets, say 1, 5, 7, and 10. We can print L, and it will give us the created list. Now, I told you that a list is ordered, so we can access the elements of the list using the index of this list. Let's say we want to access the first element of the list. In Python, the first element has the index 0, and then the second one, the index 1, 2, 3, till we reach the index length of list -1. In real life, you start counting from 1 in Python, and in many programming languages, you start counting from 0. If you want to access the first element of this list, we can say print L, open the brackets, and mention the index of the element we want to see. In this case, we want the first element, so the index 0 for the first element. We hit run, outputs 1. If we want the third element, we can call L brackets 2, hit run, and we'll have the 7. This way you can access the elements of the list you created. So we just created a list, stored some elements in it, and I showed you that we can access the different elements using indexes. Now, how can we modify this list knowing that the list is mutable, so modifiable? To modify a list, it's very simple. To modify a specific element in the list, we can call L. Let's say we want to modify the first element, which is the element of index 0. So L brackets 0, which is currently 1. And let's say we want to put 50 instead of 1. So we can say L brackets 0 equals the new value that we want to put in this first position, 50 in this case. Now we can print L brackets 0 and see that it's now 50 instead of 1. A list can also contain elements of different types, not necessarily all integers. So your list can look like 1, 3, high, 8.9. You can even put another list into the current list. So let's say 2, 3. Here notice that sometimes I put a space between the comma and the next element, and sometimes like here I don't put any space. It doesn't matter actually. So now we can print again our list. And here it's the list we created. Now, are you curious to know what's the type of this object? If we print the type of L, it will clearly state that this object is of type list. So we saw integers, floats, strings, and booleans. And now we're introducing a new type, the list, that is used to store elements. We can also print the length of the list using the len function. That is the same for strings. Hit run and see 5 because we have 1, 2, 3, 4, and 5 elements. Even if this is another sublist, but it's still counted as one element because each element separated from another by a comma is considered as one element in a list. Let's say we want to access the last element of the list. So we can either count them and say element of index 0, element of index 1, of index 2, index 3, and element of index 4. If we don't want to count all the elements, if we just know that we need the last element, what we can do is call L brackets and call the index length of L -1. Because we start counting from 0, length of L, in this case 5 minus 1, will give us the index of the last element, which is 4. So 0, 1, 2, 3, and 4. We can hit run and see this list that's outputted. It's a very practical way to access the last element of a list. We can call L brackets -1, and Python is going to understand alone that it should count the index that's in the end. So if this is 0, 1, 2, 3, and 4, we can also say that it's 0 and then whoop, -1, -2, -3, -4. And we still access the last element. Given the fact that this last element is itself another list, we can create a new variable called smaller l that is equal to L brackets -1, so this last element of the list. And we can also use indexing on the smaller list and say we want the first element of the sublist that's inside L. So let's say we only want 2. We can say print smaller L brackets 0 for the first element of the smaller L, which is the last element of L. Hit run and we'll access 2. We can even directly do this without having to create a new variable by saying print L minus 1, because this now is the last element, which is the list 2, 3. And then giving this element, we can also add other brackets and say we want the element of index 0, which is the first element of this sublist. Hit run, and we'll still access 2. Imagine now we want to slice the list and only access, let's say, these two elements here. We want to trim our list. L cut equals L brackets, and here the format is the following. You should mention your first index, semicolon, and then mention your last index plus 1. Let's say we want our L underscore cut to go from this element to this element. Our first element has the index 1, so we can replace first index by 1 here, and the last element has the index 2. So we can replace last index plus 1 by 3, because last index is 2 plus 1 makes 3. And we can print L underscore cut, hit run, and we will have the trimmed version of L. What if I want all the elements from the beginning of the list till this high element? So instead of mentioning a first index, if we put nothing instead, Python will automatically grasp that it should take all the elements from the beginning of L till the element of index 3 minus 1, which is 2, in this case, high. Hit run, and we'll have all till high. Say we want to take all the elements from the element of index 1 till the end, we can say L brackets 1, semicolon, and then put nothing, and Python will understand that we want to go till the end of the list. If we hit run, we'll have all the elements from 3 till the end of the list. So to do a small recap, if we want to select a smaller version of our list that is called L cut, or you can call it whatever you want, you can say it's L brackets index of the first element, semicolon, index of the last element plus 1. If you want to go till the end of the list, you put nothing here. And if you want to take all the elements from the beginning of the list, you put nothing here. The list has 3 main methods that can help you add elements and remove elements in a very direct way. So what is a method? A method is a function that is specific to a certain type of objects in Python. I want to introduce the method append. Let's start by creating a list that contains 1, 2, and 3. And imagine we want to add 4 in the end of this list. What we can do is call the method append, l.append, and then add the desired element inside the parentheses. We can print now L, hit run, and we'll have the 4 that's added in the end. Let's say now that we want to remove the last element of the list. What we can do is call the method pop without any argument. So arguments are basically what we put into a function. And then print L, hit run, and as you can see, the last element, that is 3, been removed from L. Let's now consider that L looks a bit like 1, 2, 3, 2, 4, 5. So there are 2 2's. Let's say we want to remove the first 2 of this list. A very practical way to do this is to call the method remove with l.remove, and here as an argument pass the value that we want to remove. Let's say we want to remove 2. We're going to print L, hit run, and as you can see, instead of having 1, 2, 3, 2, 4, 5, we have 1, 3, 2, 4, 5. So only the first number 2 has been removed. Why? Because the method remove only removes the first occurrence of the element that has been passed to it as an argument. The last theoretical aspect of the list is a small remark I'm going to give you right now. You probably already noticed that when I create a variable in Python and say L equals the list 1, 2, 3, it's a bit different from the equal symbol in math, in a sense that the equal symbol in Python is like an arrow that takes the element on the right and passes it to the element that's on the left. Let's say we have a first list called L1 that is equal to 1, 2, and 3. And we have another list, L2, that is equal to 4 and 5. Consider we write the following operation, L2 is now equal L1. What's going on here is that the variable L1 and L2 are being linked together. If we print L1, it's going to be 1, 2, 3. And if we print L2, it is still going to be 1, 2, 3 because L2 just took the value of L1. It's no longer 4 and 5, it's 1, 2, 3. What happens if we modify the first element of L2? Let's say L2 brackets 0, so index 0 for first element equals 100. And then print L2. We can see that instead of being 1, 2, 3, L2 is now 100, 2, 3 because the first element has been modified to take the value 100. However, you may expect that L1 is still unchanged because we didn't actually modify it. We only modified L2 by giving it as first element 100. But if we print L1, we will also have 100, 2, and 3. And not 1, 2, and 3, even though we only modified L2 and not L1. So what happened here is, in this level, L2 and L1 have been linked together, and any modification made on one of them is going to affect the other one. To avoid this problem, we can say that L2 is a copy by calling the copy method. L2 is now a copy of L1. So when we modify L2 in this line, L1 will remain untouched. So here, if we print L2, knowing that we modified its first element here, we're going to have 100, 2, and 3. But if we print L1, we'll have the original value of L1, which is 1, 2, and 3. So the copy method prevents any modification made on L2 to also affect L1. L2 is now a copy of L1 and is no longer exactly the variable L1. I will now give you an example of how lists in Python are useful. Let's start by creating our list called L, and that has some random values. We can start by checking the length of this list. We're going to print len of L, 9. So this list contains 9 elements. We can directly see that the maximum here is 76. What if the list was huge and you want a direct way to determine the maximal value of a list? What you can do is print the max, which is a function built in Python of L. And it will immediately output 76. Let's now say you want to output the sum of all the elements of L. Instead of max, you can call the function sum, S-U-M, hit run, and we'll have 199, which is the sum of all the values of L. Let's talk now about another object that helps storing data in Python, which is the tuple. The tuple is very similar to a list with a very important difference. The main difference between a list and a tuple is that a list is mutable, so you can change the values of certain elements after creating it. However, a tuple is immutable, which means that once created, you cannot modify it anymore. You can still access its elements, check them, take a look at them, but never modify it again. Let's take an example. Let's create our tuple called T for tuple that is equal to parentheses 1, 2, 3. We can still print T, our entire tuple, in the same way as we do for the lists. We can still print the first element, that is T of index 0, which is 1, this one here. We can still print the length of tuple, which is 3 because tuple contains 3 elements. However, if we try to modify, let's say, the second element of T, which is T brackets 1, index 1 for the second element, say want it to be equal to 100, hit run, and we'll have an error because the tuple object does not support item assignment. We cannot modify a tuple. Now, a very fun specificity of the tuples is the packing and unpacking. Let's create a tuple called fruit, in which we're gonna put apple with its color, so red. You can see here that a tuple is like a list in a way that you can put elements of different types into it. And let's print fruit. we're going to have apple red. To create a tuple, we don't have to put the parentheses. What we can do is only put two or more elements, only separated by commas, and Python will automatically detect that these elements form a tuple. We can hit run, and we can still have the same outcome. And to be sure, we can print the type of fruit, and it is a tuple. We just saw the packing, which is initializing a tuple without using the parentheses. There is also the unpacking. We want to unpack the object fruit that is a tuple. We want to separate the fruit name and the color. We can say name color, which are variable names that I am just creating, are equal to fruit, and say we just want to print the color. What's happening here is that we're doing the packing, then the unpacking, and here we're just outputting the color. Hit run, and we can see that we only have red. The way the unpacking works is by creating as many variables as there are elements in the tuple, and then saying that these elements are separated by a comma are equal to the tuple. So we are dissociating the elements of the tuple and putting each element inside a new variable that we just created. Enough about tuples. We're getting to the last object that serves for data storing purposes, which is the string. Why the string? Because a string in Python can be seen as a non-mutable list of characters. Think of a string as a list where each element is the character. Let's take an example. Start by creating a string called S that contains the sentence, good morning. A string is a non-mutable list, so you can think of it as a list and you can still access its elements like you do for a list using indexes. For example, print S brackets -1 will give you the exclamation mark, and S brackets 3 will give you the fourth element of the string, which is the character D. However, it's an immutable or a non-mutable list of characters because we cannot modify its elements. So we cannot say S index 0 equals the character O and then print S. It will give us an error saying that str object does not support item assignment. So a little bit like the tuple, the string and the tuple share the same characteristic of being non-mutable. Once created, you can access their different elements, but you cannot modify them. A list is more flexible in the sense that you can modify it. The string has also its own methods. For example, if you print s dot the method upper, it will put all the characters of s in uppercase. And let's say that here we have a capital letter and we use the method lower, hit run, we will have all the characters being reduced to the lowercase. We can transform a string into a list and a list into a string in Python using two very important methods, which are split and join. L equals s dot split, and then print L, hit run, and then we'll have a list made of all the words of the sentence S. Now imagine we have the inverse problem. Imagine we have a list made of different words. So, how are you today? And let's say we want to join all the words to form a string that is a complete sentence saying, how are you today? We can use the method join, saying that S equals quotation marks dot join parentheses list L. We can print S, hit run, and we'll have, how are you today? Now notice that we don't have the spaces between the words. The separation between the different words is specified between these two quotation marks. So when we put nothing, we have no separation between the words. When we put the space and hit run, we'll have the space separating all the different words of the list. Now let's say we want to separate all the words by dollars. We can hit run. The join method will join all the words of L and glue them by putting between them the symbol dollar to create the string S that's being outputted at line 5. Let's now tackle an exercise to have a better sense of the practical aspect of all the theory we just talked about. I want us to create a Python program that asks the user to enter a sentence, and then the Python code will output the number of words that are contained in the sentence. I invite you to pause the video and try to solve it. You can hit play whenever you're ready to see the solution. First of all, we want to ask the user to input a sentence. So we can create a variable called sentence that is equal to input of please enter your sentence. At this point, we have the sentence variable that is a string. What we can do now is use the split method to transform the sentence variable into a list. So then it would be easier to count the words using the len function to determine the length of the list, which is exactly the number of words contained in the list. List words equal to sentence dot split, and then say number of words is equal to the length lst words. So at this point, we're just inputting the sentence. At this point, we're transforming the string into a list, and here we're counting the number of words of the list. And in the end, we can output a message using the format saying this sentence contains, and here slide the number of words variable words. So this part is just the output. You can hit run. Here, enter a sentence. In my example, I'll use the sentence, the quick brown fox jumps over the lazy dog. You can hit enter, and it outputs, this sentence contains 9 words. Now, I know today's session was a bit harder than the previous lessons. However, it only means that we're increasing the level. What I want you to do for next time is try and do this exercise. What I'm asking from you is to create a Python program that asks the user to input a sentence that contains numbers separated by spaces. So 2 space 6 space 3. That is normally a string. Then I want you to use the conversion from string to list to convert this string containing numbers separated by spaces to a list that only contains the numbers. However, be careful, the numbers are still strings and not integers. And in the end, I want you to do the sum between the first number and the last number and output the final result. Be very careful to do the type conversion from string to integer before doing the addition of the first and the last element. Congrats, you've made it this far in the video. I know the level may be increasing, but so should your motivation be. Soon you'll be able to achieve very interesting tasks using automation in Python. If you like the content of this channel so far, don't forget to hit the like and subscribe button. Next time we'll be tackling the conditional programming in Python, which is a crucial topic. It helps you apply certain conditions while doing operations. Stay tuned for our next video, and don't forget, you have nothing to lose and a lot to learn. See you soon.